Hello and welcome to the Weather Unlocked video series. This is number 36, where we will discuss the capping inversion. This is Mark Birchfield of the National Weather Service in Springfield, Missouri. So what is this capping inversion? Well, sometimes it's referred to as simply the cap. It's a layer or lid of relatively warm air aloft, usually several thousand feet aloft. Now it will suppress or delay the development of thunderstorms. So take a look at this example on the right-hand side, where you have a cloud that's beginning to rise. However, it reaches this warm air aloft, several thousand feet above the ground, and it can no longer rise. Therefore, the cloud will begin to sink. So think about a lid that's on a pot on the stove. You may have something cooking, you've got all this heat in there or steam, and it's not able to come out of the pot until you release or lift the lid. That's how the cap works. Until the cap is lifted or eroded away, all that energy remains below. Therefore, the clouds cannot rise. But how exactly does this work? A little bit more in detail. So if you remember the chapter video on instability, how the cap works is that those air parcels rise into warmer air aloft and they become cooler than the surrounding air. Now, this is what inhibits the ability for those to rise and produce thunderstorms. Take a look at the example here on the right-hand side. Notice the air parcels in the stable column. Those little air bubbles will rise. However, notice that their temperature is cooler than the surrounding air. Therefore, those parcels can't keep rising and they'll begin to sink. Whereas the ones on the right-hand side will continue to rise because they are warmer than the surrounding air. So if you remember back to the SKU-T training Weather Unlocked video, where we discussed the different diagrams and how to view temperature and dew point on the maps. So this is just sort of a refresher here. On the right-hand side, you've got the temperature, how it increases or decreases with height. And then the blue line, sometimes it's green also, is the dew point temperature. Now these capping inversions are shown by the red line going to the right on the diagram. This means that the temperature is likely rising. Notice that in this example, there's about 4 different capping inversions at different levels. So it doesn't always be at one level. You could have a capping inversion at one level, and then it breaks through and continues to cool, and then you get to another level and it warms. How can you eliminate the cap? How does the atmosphere work to eliminate the cap? There's about 3 main primary ways that the cap can be eroded. One way is by heating. So getting additional sunshine, ways to increase the surface temperature to a point to where the air parcels are back to where they're warmer than their surroundings instead of cooler than their surroundings. If you've ever looked at a parameter called the convective temperature, that is a good proxy for the temperature that's needed to break the cap. So if you ever look at SKU-T diagrams like this one and some of the data that it provides, we're able to look and see what the convective temperature is. One additional way is by adding moisture to the lower atmosphere. This allows the air to remain buoyant or basically continue to rise through the ascent and eliminate the cap. So notice on this SKU-T diagram, the little green line in this case is the dew point, and it has been increased near the surface to a point to where that air parcel, that's shown kind of tracing on this yellow line, can rise much quicker and will be able to rise basically through around that inversion. However, the primary way it seems like to be the the one that really breaks the cap, is increasing lift. Maybe it's an upper level disturbance, or maybe it's a front, like some of these examples here. These fronts and these disturbances will act to force enough lift on that inversion layer to weaken it enough to allow for the cap to go away. Now the capping inversion, is an important storm ingredient. So while you have a cap in place, energy and instability, it continues to increase. Now once that cap breaks, all that built up energy and instability is then utilized for thunderstorm development. However, sometimes the cap does not break at all, and storms just will not form. And even though you had all that instability and energy ready to go, it just could not be utilized because the cap was too strong. So that concludes this video on the capping inversion. Please stay tuned for additional videos in the Weather Unlocked video series.